All right, good morning, everyone. Thank you very much for tuning in to our MTO Greenhouse Gas Reduction Initiative webinar. My name is Alan. I'm with Concrete Ontario. As always, just some housekeeping items before we actually start the webinar. This will be approximately a 45-minute webinar with 15 minutes left at the end for questions. All attendees are currently muted and will remain that way for the remainder of the actual webinar. If you do have a question, please use your GoToWebinar questions pane at the right side of your screen and type in your question. We will address all questions at the end. And this webinar will be recorded, as always, and will be posted on the Concrete Ontario website with a link to our YouTube channel. In terms of your presenters today, we have Mike Danzel once again. Thank you very much, Mike, for coming in again and helping us out. Mike did the PLC webinar not too long ago, and we always love having him come in and share his expertise. We also have Bart Canters here, the president of Concrete Ontario, and myself, Alan Carey, also with Concrete Ontario. So your primary presenter, as I mentioned, Mike Danzel. Mike is the technical services manager for the Lehigh Cement Company. He has been the technical services manager since 2010. He holds a Bachelor of Science in Chemical Engineering from Queen's University. He has prior experience in cement quality and operations with 17 years of experience in the actual industry. He is a member on CSA A3000, an associate member on CSA A231, and he's also a member of ACI. So please help me welcome Mike Danzel. Thank you very much.
All right. Thank you, Alan. All right, and thank you everyone else for attending this webinar. As you are probably aware, the MTO has recently put out some special provisions regarding an initiative for reducing greenhouse gases in concrete. So we're going to talk about those two initiatives. We'll talk about the materials within the concrete mix that we can use to apply for this credit. We'll talk about the specifics of each of the initiatives and some of the considerations and limitations around those. And then we'll open it up to questions at the end. So as we all know, cement is an essential ingredient in concrete. It's the active ingredient which is going to set and harden and give the concrete its strength and durability so we can build our infrastructure. The concrete, we know, is an indispensable construction material for the building industry and our communities, and it's one of the most robust, reliable, and the most widely used construction material around, and the most sustainable building material that we have available. Now, at the same time, greenhouse gas emissions, climate change, and environmental impact are real-life concerns, and the industry is doing what it can to manage and improve its economic footprint and the sustainability of the products and the industry in general. Likewise, a number of the government agencies have been mandated to support initiatives by the industry to reduce these impacts, and that's what we're going to be talking about today with respect to MTO. Now, to combat climate change, the MTO implemented a Greenhouse Gas Reduction Initiative on January 2018. And what they did is they introduced two special provisions that are serving as amendments to OPSS 1350 Provincial. One of them is for a 10% greenhouse gas reduction, and this is a standard where it applies to all MTO work. So this is one of those thou shalt. We have to meet this with all of the concrete. The other special provision is a 20% greenhouse gas reduction, and this is a demonstration where they're going to have select projects where they're aiming for a 20% reduction, and that will help them to gather some more information and study a little bit further. And as it stands right now, I believe there's 6 projects out there where they have this 20% reduction target. Now, the one thing we still have to consider is that no matter what the greenhouse gas reduction is that we're pursuing, we still have to make sure that the materials we're using and the concrete mix designs are going to be optimized to ensure that we're going to meet all of the performance requirements for the concrete and the project. So we have to meet all of the requirements for strength, for durability, RCP, and whatever else. Plus, we've got the greenhouse gas reduction targets on top of that. So the purpose of these amendments is to use the available resources that we have at specified replacement levels to achieve a greenhouse gas reduction of either 10% or 20% over a basic concrete mix. And you can achieve more than that if you want. If you want to go for 12%, 15%, or 25%, you know, that's perfectly fine. But those are the minimums that we have to meet there. And we're comparing that to a basic old school mix, you know, 100% Portland, you know, this is what it is. How can we reduce the carbon content of that? So the materials that the MTO identified as being applicable to this are Portland limestone cements, supplementary cementitious materials such as slag or fly ash, and in some cases silica fume, and limestone fillers. Unfortunately, this does not include other methods of innovation and optimization, such as optimized combined aggregate radiations, add mixtures, and other technologies that are out there. So it's a very, very basic outline that they have right now at the moment. So Portland limestone cements. These are cements manufactured with up to 15% interground limestone. And if you were on the last webinar that we had a couple months ago discussing Portland limestone cements, you'll find some more information about them. But basically, they are very similar in performance to the regular Portland cements. They have the same workability, they have the same strength characteristics, the same durability, and so forth. But we achieve about a 10% reduction in our carbon and other emissions with the Portland limestone cements. And that is because what we're doing is we are diverting a portion of the limestone that would be used during the pyroprocessing past the pyroprocessing stage and incorporating it in the end with the milling. And by doing that, what we're doing is, we all know that limestone is calcium carbonate. With the cement clinker, we're interested in the calcium oxide, which means we're going to flash off the carbon dioxide. So since we're taking 10% of that limestone and diverting it past that stage, incorporating into the end, we're not releasing that 10% carbon dioxide, which would be from the calcination and the fuel consumption. Now, typically, the Portland limestone cements, they're a little bit finer in the particle size, which helps improve the particle packing, and that enhances the reaction rate and establishes nucleation sites. It reduces the porosity of the cementitious hydration product matrix. And we also form carbon aluminates from that, from the carbonate from the limestone and the aluminates from the clinker during the hydration, which is going to help to further reduce the porosity. And on top of that, the Portland limestone cements, they tend to work very, very well with slag and SCMs because of that carboaluminate reaction where you've got more aluminates available from the SCMs, and they stabilize the sulfoaluminate and sulfoferrate phases. Now, Portland limestone cements, the specifications on that, they fall under CSA A3001, OPSS 1350. It's recognized by the National Building Code, and it's been well accepted in Canada. And we are considering that the Portland limestone cements provide us with a 10% greenhouse gas reduction, because instead of incorporating 5% limestone like we would in a conventional Portland cement, we're going to be incorporating around 15%. So that's where we're getting that 10% greenhouse gas reduction number. If we're using limestone cements in MTO works, the cement must be on the DSM list, the Designated Source Materials list, where we can find that on the roadauthority.com website. it may not be used in MTO works in a sulfate environment. And this is something specific to MTO only at the moment. It is allowed under CSA 823.1. There was recently an amendment a couple of months ago published that just aligned that with the cement standard, and basically it's treating the limestone cements exactly the same as a regular Portland cement, where it has to meet the sulfate expansion requirements. And the other consideration with the Portland limestone cements for the MTO works is that we may not use a limestone filler with the Portland limestone cements. So it's only one or the other in this case. Now, supplementary cementing materials, these are industrial byproducts from the iron industry, from the coal generation industry, where we're looking at slag or fly ash that they can't use. And instead of landfilling the material, we've found a use for it in our concrete. And what these materials do is they will react in the presence of calcium hydroxide. And when we look at the basic cement and water chemical reaction, and this is a simplification of it, but when we mix cement and water, we're going to generate calcium silicate hydrate gel, which is the good stuff that gives our concrete the strength, the durability, it bonds everything together. But we also have a byproduct produced during that reaction, which is calcium hydroxide, which, although it is stabilizing somewhat, it's relatively inert in the sense that it doesn't add a whole lot to the strength or durability of the concrete. And that's just the natural byproduct from it. The supplementary materials, they will react with that calcium hydroxide or in the presence of it with a secondary chemical reaction, and it's going to form more of that calcium silicate hydrate gel. So that's why we get those improvements to our later strengths and a much improved durability and permeability of the concrete. Now, each of those individual SCMs shall be limited to the maximum replacement level for the material permitted by the contract. And in most cases, your maximum for fly ash is 10% or slag 25%. Although I do believe there is a special provision out there where, for example, with slag, you could go up to 35%, but that's assuming that you're willing to do salt scaling slabs yourself for the MTO to provide them with further information on the salt scaling resistance at higher levels. So typically, you're looking at that 10% and 25% number for the fly ash or slag. Now, the supplementary cementing materials, again, they fall under CSA A3001, the cement standard, and OPSS 1350. Slag and fly ash will be considered a direct replacement for the GU cement in the mixed design, and the replacement percentage considered as a direct greenhouse gas reduction. So if you have a concrete mix and you're running 20% slag replacement, then you're getting a 20% greenhouse gas reduction in that. And this is basically simplified math just to keep things simple for the accounting. So this is how they are crediting those numbers. Now, for the 20% greenhouse gas projects only, the silica fume cement is going to be considered as having an 8% reduction, because typically the silica fume cements are somewhere around 8.5% replacement. Again, these materials, if you want to use them, they must be on the MTO designated source list or designated source materials listing. And those limits that they have on the SCMs, the 10%, the 25% for the slag or the fly ash and the slag, those still apply. Limestone fillers. These are limestone powders used as an aggregate to reduce the paste demand of the concrete and thereby reduce the cement content. And these fall under CSA A23.1 Annexes L and L2. It's mentioned in A3001 4.4.3 and OPSS 1002 specification on mineral filler. Now, some considerations with the limestone fillers. They may not be used with the Portland limestone cements. Again, it's only one or the other. There's a restriction that with the limestone filler, if you're using it, it can only be included up to a maximum of 15% of the cement mass. The other thing we have to consider is that it may not be used in the calculation for the water to cementitious materials ratio, and it may also not be used in a sulfate environment. So some example uses where the limestone fillers really shine is where you're looking at the stuff like self-consolidating concrete mixes or a low-strength pump mix, etc., where you need some powder volume in there to modify and enhance the rheology of the concrete, but you might not necessarily need the strength that would come along with going with an overly high cement content in the mix.
I guess just one thing we should mention is that limestone fillers is an aggregate. It's not a cement per se, correct, Mike?
Yes, that is correct. It's being considered as an aggregate in here, and it's a little bit confusing when you read the specification, but hopefully we've got a good handle on it here in the presentation with a demonstration calculation coming up that kind of walks through that with how it's considered. So, the carbon dioxide, it must be calculated based on the cement reduction of a previously utilized MTO concrete mix design. So, for example, if your previous mix design was, a standard old school city sidewalk mix with 355 kg per meter cubed of type GU cement, the maximum amount of limestone filler that you could have in your concrete would be equal to those 355 kilograms per meter cubed times 0.15, because we're limited to a maximum of 15% of the cement mass. And that gives us a maximum amount in the mix of 53 kilograms per meter cubed. So if we added those 53 kg of limestone filler to our concrete, and we found that we were able to reduce the cement content down to, for example, 315 kg per meter and still meet the same strength, water cement ratio, and durability parameters, then the cement reduction would be 355 kg minus 315 divided by 355, the original cement content, times 100, would give us a reduction of approximately 11.3%. And the other thing we have to consider, again, as I mentioned previously, is that it doesn't factor into the water cement ratio. So if your water cement ratio maximum on this mix was 0.45, then your corresponding maximum water content would be 315 kg per meter cubed times 0.45 water to cement, which equals 141.75 liters per meter cubed of water. And this was an example that we also got, that we talked with Mohammed at the MTO, Mohammed Akel, just to make sure that it was being accounted for properly. And this was kind of the example that he came up with. So we're fairly confident with how this is being done. So, with the MTO greenhouse gas reduction initiatives, what's required for 10% and 20%? How do we achieve the 10 and 20% greenhouse gas reductions? And what considerations and limitations are present? So, the 10% greenhouse gas reduction is applicable to all MTO contracts and will be the basis of the initiative. Again, as I mentioned, this is one of those thou shalt conditions. Everything that we do with MTO works, we have to meet that 10% reduction. So to achieve at least a 10% greenhouse gas reduction, we have to use one or a combination of the following options. One, we can use a Portland limestone cement, and that counts as our 10% greenhouse gas reduction right there. Two, we can use slag or fly ash, up to 10% replacement of the cement content. And again, that will give us our 10% greenhouse gas reduction. We can use a combination of the Portland limestone cement and the slag or fly ash and achieve more, of course, if we want to. And the third option is the use of a limestone filler to reduce the cement content of the mix by at least 10% through the enhanced particle packing and optimized gradations and improvements to rheology and other means. But we have to consider, again, with the limestone filler, we can't use that with the Portland limestone cements, although we can use it with the slags or fly ash to achieve the 10% or more reduction if we want. The 20% greenhouse gas reduction is classified as the enhanced reduction, and that's going to be used for certain demonstration contracts. To achieve at least 20% greenhouse gas reduction, we have to use one or a combination of the following options. The use of supplementary cementing materials, slag, fly ash, or silica fume, to replace at least 20% of the cement content of the mix. Or we can use a Portland limestone cement and a minimum of 10% supplementary cementing materials. So if we used Portland limestone cement and 10% slag, that would give us our 20% reduction. Or we can use a combination of the limestone filler and the supplementary cementing materials to ensure that we get a 20% reduction to the cement content where the mix is being replaced, or where the cement is being replaced and reduced. And again, with the limestone fillers, they're not allowing using that with the Portland limestone cements. So with the 20% greenhouse gas reduction, there are 6 contracts that the MTO has put out where they are mandating this 20% reduction. There's the Highway 401 bridge rehabilitation at Highway 404, the bridge rehabilitation at Highway 401, 403, 410 interchange, the bridge rehabilitation at Highway 401, 403, 410 interchange, westbound and eastbound, Baldwin Street parking lot in Whitby, Highway 7 and Perth Line 26 roundabout, and the Nicholas Street underpass replacement at Highway 417. So some of the critical factors that we need to consider when we're looking at this. The GU and the GUL cement may not be interchanged in the same component. This is expressly forbidden in the MTO specifications. Once we've selected one of those materials, we have to use that for the rest of the project to complete that component. Another consideration, that greenhouse gas reduction limit, be it the 10% or the 20% target, must be met on each and every individual concrete mix design submitted on the project. It's not being based on the average greenhouse gas reduction for the entire project. Every single mix has to meet it. So you can't, for instance, do half of your concrete at 20% and half at 0% and have it count as 10%. Each mix has to meet that 10% or 20% reduction minimum. And another consideration is that a high-early strength Portland limestone cement is not readily available in the Ontario marketplace at this time. So as such, some applications, particularly fast-track concrete, that requires the use of high-early strength cements, will have to achieve the greenhouse gas reductions by utilizing the SCMs or the limestone fillers, which it can be challenging with higher SCM replacement levels to try to get those high-early strengths. So this is something where you might consider talking with the CA to see if you can maybe get an exemption for that particular mix, if they will allow that. Some other limitations to keep in mind. The slag shall be limited to the maximum of 25% by mass of the total cementing material. The fly ash shall be limited to a maximum of 10%, except where we're looking at silica fume overlays and high performance concrete, where up to 25% is permitted. A mixture of slag and fly ash is allowed up to 25% as long as you're not going over 10% with your fly ash. And again, that restriction on the 10% fly ash is not applicable to the silica fume overlays in HPC. The limestone filler is restricted to a maximum of 15% of the original cement content by mass. The limestone filler is not included in the water to cementitious materials ratio calculation, and the Portland limestone cement or the limestone fillers shall not be used together or separately in concrete exposed to a sulfate environment for the MTO works. So some applications where the concrete producer should request an exemption. Again, we're looking at those early strength development type projects where we're looking, 4 hours, 6 hours, 8 hours to open it back up, wanting to hit 15, 20, 25 MPa in a short time frame, or other early strength mixes. But what you want to do is try to reduce the CO2 contribution of the mix design and request an exemption for those applications where you're not necessarily realistically able to reduce the greenhouse gases. So in summary, we have a 10% standard reduction that's required for all MTO works and 20% reduction required for some demonstration projects. The Portland limestone cement, that's considered to give us a 10% reduction to the greenhouse gas emissions. SCMs, the reduction is equivalent to the replacement percentage for the slag and or fly ash or the silica fume on the 20% reduction demonstrations. And the limestone fillers, we must quantify the cement reduction over our old standard mix design. The concrete must still meet all of the performance requirements. So we have to meet our requirements for strength, AVS, and so forth for the contract. And all of the material requirements and specifications and maximum replacement levels from the OPSS specifications still apply. So, moving forward, moving forward, the MTO is going to be updating the Form A and Form B mixed design submission documents to allow the concrete producer to clearly indicate for each mixed design what the greenhouse gas reductions are going to be. And we have to consider that the Concrete Ontario's mixed design is intellectual property. The requirements still apply, and any mixed proportion information should only be provided on the Form B mixed design submission, as that is protected under the existing Memorandum of Understanding between the MTO and Concrete Ontario. So, we can open it up now to any questions?
Okay. So the first question is, how do we show conformance to these requirements to the contract administrator? You just touched on that. Yeah, again, the MTO, they're going to be updating the Form A's and B's, and there's going to be a box in there where that number is going to be quantified. Okay. What concrete performance changes should I expect if I replace my GU with GUL cement? The GU and the GUL cement, they have been designed to offer equivalent performance to one another. So the strength with using the GUL, the durability, the workability, and so forth are going to be equivalent to what you would have, if not better, than a conventional GU cement. The mix design modifications are very, very minimal. Generally, you can swap one in and one out, and you won't have to make significant adjustments to your mix design. Maybe just a slight change to your admixtures. You might need to maybe increase or decrease, maybe 10% switching from one to the other. But for all intents and purposes, the performance is equivalent or comparable, and the materials are designed to be
easily incorporated into the concrete.
Okay, sticking with the GUL questions, does using GUL cement prevent me from using my existing 25% slag? Do I need to reduce my slag down to 15%?
No, you do not. If you want to run with a Portland limestone cement, which gives you your 10% reduction, and continue to use 25% slag in your mix, by all means do that. As you know, the performance of the concrete around 25% slag is going to be much improved over having no slag in there, because it's going to improve the strength and durability of the concrete. And further to that, you know, that's going to actually net you about a 35% reduction, even though you might not necessarily get credit for that under this program on the MTO with how they've got it set up. It's still the right thing to do for the industry.
How do we address customer concerns in the spring and fall regarding set time issues?
Well, that's where you would want to look at what your typical spring or fall mix would be and use that as a comparison. When you look at the SCM replacement levels, if you're looking at the slag in particular, you can get some lengthening of the set time at higher percentages, but if you're running around 5 or 10% slag, there's not too much of an impact to your setting times at that time. But again, you know, that's where you can really get a lot of bang from your buck from some of the admixtures that you're using, whether you're using some of the higher end water reducers and polycarboxylates or accelerator. But at the same time too, you know, you can compare that mix to what you would originally have during those times.
Okay, next question. OPS 1359 specification for U-fill sets a cement content of 25 kgs. How do we address this?
Well, if you're using your Portland limestone cement, you get
5 kgs of slag and you're good.
And yeah, I mean, it's just really small numbers. I mean, those mixes, it's primarily aggregate in there. So it's kind of a funny thing, but yeah, you know, if you just use your Portland limestone cement or your small little portion of slag, there you go, you get your credit.
Yeah, limestone filler, because of that 15% limit, it's pretty, there's not very much that you can put in for that application, unfortunately. Does the limestone filler used need to meet any current specification?
Just those that were listed before, where it's referenced in, I believe it's OPSS 1002 for mineral fillers, and whatever references they would have within that specification back to at the CSA or ASTM.
Okay. Why is the MTO limit on slag currently only 25% when significantly more slag can be used in commercial applications?
Well, that's really a question for MTO, but they are trying to be conservative and ensure the durability and the performance of their materials. So they are being careful with what they do with the specifications, and they limit the slag to 25% because they do have concerns about a structure that's going into use shortly after being placed. So they want to, part of it is they want to make sure that you know, a few weeks down the line, this particular concrete element is going to be mature enough that when it's in use, it's going to be durable and not suffer any sort of damage or anything to that effect.
Okay. Do you anticipate the 20% reductions to be the next benchmark for the industry? What can we do to prepare for this?
You know, maybe looking down the road, they might move towards more of the 20% reductions as they get some data and get comfortable with that. To be honest, it's really not that hard to meet that. If you use 10% limestone cement and 25% slag, for instance, you're hitting a 35% reduction there, no problem. So in terms of, preparation for what we can do, I don't think it's too difficult. As for whether they will do that or not, I would expect, down the road, it might be possible that they might consider pushing towards those higher targets.
Okay. Is the specific gravity for Portland limestone cement the same as that for GU cement?
Actually, it's close enough that it doesn't make too much of a difference. If you look at the GU cement, the standard number for the specific gravity is 3.15. With the Portland limestone cement, the last measurements I saw, I believe it was like a 3.13 or a 3.14. So it's pretty much essentially the same thing. When you actually calculate it through for your yield and your concrete mix design, I mean, you're not even looking at like a kg difference. It's hardly even rounding error.
Okay. Are there currently any limitations on the number of aggregates that can be used on an MTO project? I don't think there are. I think it's really a operational issue on bin capacity.
Yeah, I don't think there is any limitation other than the fact, each of those materials, they have to meet the specifications. So if you wanted, to add 4 different aggregates, as long as they were on the designated source materials list and the mix submission was approved, I believe you can.
Yeah, there's been some recent technical bulletins out on combined gradations of aggregates. So as it sits currently, you have, as long as the coarse aggregate or the fine aggregate fully conforms, you can use as many as you like. You can use combined gradations with additional testing requirements to blend aggregate materials together and still conform, but there's extra testing required.
Yeah, and I think it's the linear shrinkage that you're looking at doing with that, and you have to kind of split out based on the size fraction with the gradations and the testing.
Yeah, and then the other practical comment that someone's just raised as well too is the MTO forms need to be updated to allow for more lines to list all the different raw materials that we're now using so that you can have multiple aggregate sources. So that's our technical committee and our MTO liaison committee have already reviewed the draft forms and provided comments back to the MTO. So we're hoping to have, our next MTO liaison committee meeting is September 17th, I believe. So we're expecting to have an updated form there. One of the challenges, we're going to basically a page and a half now on the form because we're trying to add in all these new boxes. Next question. How do we obtain exemptions from these requirements for early strength concrete mix designs?
That's where you would probably have to identify a reason why you wouldn't want to pursue it on there, and what the potential impacts of the project would be if you did try to pursue it. And that I would expect you'd have to take up with the contract administrator to see if an exemption could be applied in that instance.
Yeah, so again, if you're in the tendering phase, then we always request that you, through your contractor, put in a tender clarification request to identify those issues before the tender closes. After the tender closes, then again, it's a change order request through the contractor. If you're having any technical issues, please contact Alan Carey or myself here at the association so that we can help you. Again, as Mike indicated before, the whole objective here is to reduce the CO2 contribution of the mix. If you've got a fast-track mix design where we're putting in supplementary cementing materials and then still upping the cement content of the GU to hit the early strength requirements, we're really not achieving the ultimate objective, and it's pointless to be doing that. And the MTO acknowledges that there are some unique situations where that will arise, so we just need to bring it to their attention, show them why it doesn't make sense, and then we'll deal with it that way.
Yeah, we don't want to shoot ourselves in the foot to make things worse.
Okay, the next question here, which maybe I'll answer, how does the MTO Greenhouse Reduction Initiative relate to the industry average concrete mix design EPD project? Really, they don't relate that closely. The EPD project, we came up with our average mix designs for 25 different individual mixes, and then we did surveys with all of the membership to identify energy usage at the plant, fuel usage for trucking, and came up with basically what the average impact was. What the MTO is looking to do here is a fairly simple way to quantify CO2 reductions. So we're just trying to do it very simply through the mix design submission process rather than doing really detailed calculations on CO2 contributions. So again, that's possible, but that takes it to a whole nother level when it comes to the amount of calculations that have to be done. Okay, that wraps it up, it looks like, for the questions that we had. Thank you, Mike.
All right, well, thank you, everyone who was on the call and webinar. And
we just had one more come in last second here. When using portables with only one silo for MTO jobs, how can you obtain the minimum 10% greenhouse gas reduction instead of increasing the cost of moving additional equipment to the plant site?
Well, this is one where if you were using a Portland limestone cement, you'd get that 10%. But you know, if that wasn't feasible, or if it was something with the 20%, that's where you'd have to have that discussion, like Bart mentioned, with the contract administrator to figure out what's realistic, what's feasible, and what can be done moving forward.
Yeah, we've even had some of our volumetric members that have indicated they've switched over to GUL cement and not had issues with producing that as well too. So I guess that's an area where you should talk to your cement supplier, see what's available as far as GUL delivery, and then talk about the performance options and what you need to do to try and address that from a mix design standpoint. Okay.
Well, Mike, thank you very much for coming in again. You're definitely a savior, and you provide some great information to the industry, and we love having you here. In terms of the webinar itself, that wraps up our GHG initiative aspect. Some upcoming webinars that we do have, September 19th, we're looking at structural shotcrete applications, which will be very interesting. In October 23rd, we're going to have Hannah Schell come in, talk about some MTO specification updates. November 14th, we're going to look at concrete chute secondary restrainment methods. We had to move this one up a little bit. In December 12th, we're doing seasonal loads, which is always a very important topic. January 17th, we'll look at some MOE plant inspections and how to prepare for them. And then finally, around February, we're going to be looking at the new supplementary cementing material, ground glass, which is being implemented in CSA. I think that wraps up our webinar for today. Thank you very much, everybody, for tuning in. Thank you again to Mike, to Bart, and hopefully everybody tunes in on September 19th for shotcrete. Thank you very much, and have a great day.